LAT by my PC, and today I'm making a tutorial about isometric rotation, and I got a background to match, as you can see. So when I re-uploaded my isometric tutorial on SynForge Tutorials, by the way, if you haven't watched the isometric tutorial, I would recommend you watch that first before you watch this. I got a comment saying, "Oh, good tutorial, but you forgot the most important thing. How do you rotate it?" And I would respond, rotation is not the most important thing. I think that getting the player to overlap behind things is the most important thing, but all the same, rotation is very cool. I usually don't go ahead and make things when I get new response because I don't have time to respond to every single one, but this one I thought was kind of interesting, and it turned out to be a lot easier than I expected. For that reason I make a tutorial about it. So I'm going to start off. We're going to talk about the process of drawing isometric shapes, or at least the rectangular types that I usually draw. So you start off with the base. So just a simple rectangle, and then we're going to draw the top of it, which we want to be the same dimension as the base, so like that. And you can put this anywhere you want. You make an isometric shape no matter where it is. Okay, and then you draw lines to connect the dots, and then you end up with a parallelogram on each of the faces on the side. Okay, so now we have 4 parallelograms on each side, and we have a top and a bottom, and then you'd go about filling it in. So there you have filled in the top, and you can imagine you filling in the bottom ones because that's a little bit trickier. I guess I could go ahead and delete those sides you can't see. So that is the process of creating isometric shapes. That's all there is to it. Find a base, find a top, draw parallelograms to connect them, and you're good. Alright, so I made a little program to illustrate how you can do this in GameMaker. I'm moving the top of it in circles, and then I'm drawing lines to connect the top to form a somewhat three-dimensional shape. Notice I'm using triangles because you can't draw parallelograms in GameMaker. This held me up at first, but then I realized that you can just make 2 triangles to make a parallelogram quite easily. This is really the main trick to it. There's nothing 3D about this. I'm simply drawing triangles depending on the orientation of the square on the top. And if you take it a step further, you can fill in the triangles and the top, and then they look like solid walls. Notice that only 2 are visible at a time, so when we code this, we're going to take that into account and only draw 2 at a time. That way you don't have to worry about which one of the faces needs to be in front or not. We'll just draw the 2 that we need. Okay, and here's the really cool part. As it is now, it's just a little weird animation where you're moving the top around and it's affecting the stuff around it, but if we rotate the view in the opposite direction while rotating this thing, it looks really cool in 3D. Here we go. There you go. That's what we're going to aim for. That's the effect we're going to aim for. Again, there's nothing 3D about this. It's just an illusion that makes it look 3D. All I'm doing is I'm rotating I'm moving the top part in circles around it. I'm drawing faces to connect it, and then I am rotating the angle of the view to make it look 3D. Okay? That's what we're going for. Now, without any further ado, let's get started in GameMaker. So, I'm going to go ahead and create a sprite. This is going to be a black box. So, I'm just going to call it block. Create a sub-image. I'm going to make it 64 by 64. I'm going to fill it in black, and that's it. This will not be visible to the player. Everything that we will be drawing is going to be done in the draw event. But it's nice to have a sprite when you're setting it down. So now obj block, give it the sprite, and then in the creation event we're going to set up 3 variables. We're going to set up the height. I'm going to set it to 100 or so. That is how tall our block is. So basically how far the top is from the base is what it's going to come down to. The quadrant. There are 4 quadrants, and we're going to need to code it a little differently depending which quadrant it's in. That would depend on which faces we draw and the depth of the particular object. That's what the quadrant is for. We'll go more into that later. And now, last but not least, there is rotation, and that's equal to 90, so it'll be pointing upward to start with. So this is the current direction that we're pointing in. So this will be the angle that the top of it makes relative to the base. Okay, moving right along, let's go into sub event. So now we're going to go more into the quadrant thing that I was talking about. So if rotation, if it's let's see, if it's more than 0, and rotation is less than or equal to 90, then we're going to say it's in quadrant 1. So quad equals 1. Fair enough? By the way, you might see that I'm putting semicolons behind it. You don't have to do that. I've just been doing Java a lot, so it's become a habit for me, and it's preferred in GameMaker, so I figured I might as well do it. We have 4 sections for each of the 4 quadrants. If it's between 90 and 180, we want it to be in quadrant 2. If it's between 180 and 270, it can be in quadrant 3. And if it's between 270 and 360, it's going to be in quadrant 4. So this correlates with the quadrants of the unit circle. If you learn about the unit circle yet, if you haven't, don't worry about it. So I'm going to move on to the next step. So quadrant 1 is where it's in the top right, where it's pointing up and to the right. Quadrant 2 is where it's pointing up and to the left. Quadrant 3 is where it's pointing down to the left, and then quadrant 4 is where it's pointing down to the right. So that's what you have right there. So now we're going to move on to our next problem. We're going to need different depths for the objects depending which quadrant we're in. So if we're in quadrant 1 up here, you'll see that this one in the bottom left is the closest to the camera, I guess. It's drawn above everything else, meaning it has the lowest depth. So you want this one on the top right to have the highest depth. So if we think about it as x, so one of the highest depths in this case has the highest x and the lowest y. So for quadrant 1, we want depth to be equal to x minus y. So as x gets greater, it'll increase the depth, and as y gets greater, it'll decrease the depth because we want the y to be lower for that one. Okay. Quadrant 2. For this one, bottom right is drawn above everything else. That one has lowest depth. Top left has the highest depth, and that one has the lowest x and the lowest y. So we want negative x, negative y. Depth equals negative x and negative y. Alright, moving right along. For this one, the bottom left has the highest depth. So that's highest y, lowest x. Depth equals negative x plus y. And the last one, this one, that is highest y, highest x. So depth is equal to x plus y. So this is the depth only is applied when you have multiple objects. So now that we've got this part done, this is the quadrants. Okay. Now I want to code for changing the rotation. So I'm going to say if keyboard check BK right, then I want rotation to be I want 2 to be added to the rotation. There, equal sign. Alright. And then I'll copy this, and then if we move to the left, I want 2 to be taken away from rotation. Then we want to modify rotation. In order for this calculation to work, it needs to be between 0 and 360, which are all the possible degrees, but the problem is with this, it's possible for it to go above 360 or below 0, so we want to make sure it doesn't happen. So if rotation is below 0, we want to add 360 to it, which is one full circle, so it really shouldn't make a difference. The only problem where this can not work is if it becomes below negative 360, then adding 360 will not be enough. Equal sign there, I'm silly. So if you're ever rotating at a faster speed than 360, then you could have problems there, so keep that in mind. And then to make sure it doesn't go above 360, rotation is equal to rotation, I can't type today, rotation mod 360. Alright, this is a slightly more powerful one than the previous one. If it's like above if it's at like above 720 or above 1080, then this will still work because it will take the remainder when it's divided by 360. So this will basically say if it's above 360, bring it down to where keep subtracting 360 until it's below 360. I made a tutorial about mods on this channel, by the way. If you're interested, you can go ahead and look that up. Alright, so now we got that taken care of, we can go and take care of the draw event. Before we draw out the triangles, we need to accept some new variables. I'm going to say dx, dy. So these are going to represent how far away the top is from the base. So I'm going to set dx and dy. So how far away is it in x direction, how far away is in the y direction is what it's saying. So this is going to depend on our rotation and our height. So I'm going to say height times cosine of rotation. And this rotation is in degrees. In order for the cosine to work, we need to multiply it by radians. We need to convert it over to radians. In order to do that, we multiply it by pi divided by 180. You don't have to understand where I got that from. It's a math thing. If you don't know what radians are, it'll be tricky for you to understand it. But I recommend that you learn about radians at some point. Take the time to. Well, how did I get that? I'll show you. Let's go back to paint.net. And I will delete my layers. I'm going to go ahead and draw a triangle. Alright, so this triangle represents when our angle is, let's see, when our angle is like that. Can't really draw very well with my mouse. So then, roommate's coming in. This will be our height, and this will be the dx. Hello, Cody. Making a tutorial. And this will be the dy. So from this part, we can use trigonometry to figure out our dx and dy. So for our dx, we're going to use cosine because cosine is the adjacent side over the hypotenuse. We get, let's see, cosine theta is equal to adjacent divided by hypotenuse. So in this case, it'll look like that. Then we want to rearrange it to solve for dx. So we multiply both sides by h. So h times cosine theta, or our rotation in our case, is equal to dx. Next part, to solve for dy, we'll use sine because that's opposite over hypotenuse. So we get sine theta is equal to our opposite side, which is dy, divided by our hypotenuse, which is h. Then solve for dy, so you get h times sine theta is equal to dy. There you go. There's the short proof of how I got that stuff. So that's where that comes from. And then for this part, it's like height times sine of rotation times pi divided by 180. If this is confusing to you, just wait until I take trigonometry in high school, and it'll make more sense to you. Okay, so I'm going to create two more variables. Set x2 and y2, and this is going to represent the opposite corner. Okay, so I'll explain that in a second. So x2 is equal to x plus sprite width, and y2 is equal to y plus sprite height. Okay, if we have the base of our object right here, we're going to say that that is at x, y, because that's how GameMaker set up. The top left corner is xy. Or in order to draw our parallelograms connecting to the top, we're going to need to use the bottom left corner values as well. So therefore I set this one up, and that's x2, y2. And we can define the other corners using those variables. So this one would be at a different x but the same y, so x2, y, and then this bottom left would be switched. So that would be y2, x, y2. Okay? So that's why I created the x2, y2, so I can reference it in that manner. Alright, so that's how I got that. Now we're going to go on to some part, and we're going to go and draw our triangles. Draw triangles. And we're going to start with side 1. So this will be the right side. Okay, so first thing before we draw it, we want to know when it's visible. So the right side is the green side in this case. So here in quadrant 1, it's not visible. Quadrant 2, it is visible. Quadrant 3, it is visible. And then quadrant 4, it is not. So we only want to draw it if we're in quadrant 2 or 3. So if quad is equal to 2 or quad is equal to 3. Again, these parentheses aren't necessary, just Java syntax I've become used to. You can add them if you want, or don't add them, as you will. So, let's see. I'm going to set the color up, draw set color, and I make it green, just so we can have it correlate nicely with my demo here. Next we're going to go ahead and draw our triangles. So draw triangle. So you can see here we have 6 or 7 arguments representing the XY values of each vertex, then whether it's an outline or not. So referencing this diagram again, it's this triangle is going to use. We have one triangle that's going to use the top right corner of the square, bottom right corner of the square, and the bottom right corner of the top square. So we'll go and draw that one first, I guess. So top right of the base, that would be x2 comma y. Bottom right of the base is x2 comma y2, and then the bottom right of the top, it's basically taking the base value in the bottom right and then adding our dx and dy, or applying the height to it to find the other one. So that would be x2 plus dx and y2 plus dy. So that's where these variables come in. And because in general math, the more y, the higher up you are. That's what this is assuming, but in programming, generally, the more y, the lower you are. So therefore, we're going to need to subtract dy instead of add. And then, do you want it to be an outline? Do you want it to be outline? True or false? False. We want it to be filled in. Okay. Okay. So for our next one, we're going to need to draw along the 2 right ones at the top, and then the top right one at the bottom. Top right at the top. So we'll take the top right on the bottom, which is x2 comma y, and then we'll add dx, and we'll subtract dy from them. Okay. Now, next, bottom right of the top, so that's x2 comma y2, and then we'll apply the dx dy thing to it. Subtract dy, and then we're going to need top right of the bottom, because for this one we use the bottom right of the top. So in order for the triangles to mesh together properly, we'll need to use the top right of the bottom. So that would be x2 comma y. So just try to visualize a triangle in your head as a triangular mesh, I guess, as I was showing you in the original example, and then you'll get the values from there. I'm going to go through these other ones a little bit faster. So next one, side 2, which is going to be the top side. So it's yellow in this diagram. We're in quadrant 3 right now, so quadrant 3 is visible, and quadrant 4 is visible, and each one is only going to be visible in 2 quadrants, so I'm not going to bother checking the other ones. So that's when quad equals 3, or quad equals 4. And this is going to be side 2, which is the top side. Okay? Okay, I'm going to set the color to yellow, draw set color, see yellow. No. Okay. Okay, I'm going to go ahead and copy this stuff, I guess. The top 2 points on our base, which is going to be x comma x and x2 comma y. Then we'll choose one of the points from our top part, which, let's see, what should we make that one? We'll make that the top right. So that would be coming off of our top right of the base one, which is x2 comma y, and we'll apply dx to it and dy. Subtract dy. And that, I believe, is 3 points. Yes, it is. Okay, move on to the next one. Okay, so this one we only need 1 from the base, and since we use the top right one for the first one, we need to use the bottom left one for the base. So that would be x comma y. Okay, now we need the values for the top part, which is x comma y, and we'll apply dx and dy to those. Subtract dy, and same for the next part, y2, x dy2 plus dx minus dy. Halfway there. Side 3, which is going to be the left side. And by the way, if you find this confusing, I had to redo values all the time when I was going through this the first time because I messed up so many of them. Now I've sort of developed a technique for it, so that's why I'm able to do it a little bit faster. But don't feel bad if you don't get this right away. So left side, that's blue. Quadrant 1, it's visible. Quadrant 2 and 3, it's not. And quadrant 4, it's visible. So quadrant 1 or 4. So quadrant's equal to 1 or 4. And that one is, what did I make it blue? Oh, yes, I made it blue. So I'll make that blue. This part, let's see, we have x, y, and the bottom left, which is x, y2, and then we'll go with the top left for the top part. And let's see, what is that? So we start with xy and we apply dx dy to it. So add dx, subtract dy. Okay, next part. Last time we used top left for the top one, for the top part of it. So now we're going to use bottom left for the base of it. So that would be x, y2. No, that's it. Okay. And then for the other ones, we'll go ahead and apply dx dy to it. So x, y2 with dx and with dy. Then x, y with dx minus dy. Alright, 3 done, 1 more to go. Side 4, which is the bottom side. Quadrant 1 is visible, and quadrant 2 is visible. Side 4, bottom, quadrant 1 and 2. And I made this red. Almost done. Okay, so that is dy2, no, xy2, and then x2, y2, the bottom left of the top is what we'll use. Okay, so now for this one we use both the tops, so that's x, y2, both with dx and dy. Then top, okay, bottom right of the top one, which is x2 plus dx, y2 minus dy. Then bottom right of the base, which is x2, y2. Okay, it'll be a miracle if I actually got every single one of those right, because it's really tricky. Now we're going to go and draw the top, which is a simple rectangle. This should be a welcome change to the previous one, so draw, set color, set the color to black, and we're going to draw a rectangle. This is a top, so all the values need to be modified for dx and dy. So the top left of the top thing is xy with the dx dy modifications, and then the bottom right is x2 y2, the bottom right y2 again with our dx dy modifications. Is this an outline? No, it's not. Whew. Alright, so now that that's done, we should probably be able to make something out of this. Let's hope I don't get any glitches, but then again, the odds, let's be honest, I'll probably get a glitch. Okay, now I got a room set up and we should be able to test it out. Alright, so starting up on a board, and you can see the red side, and then if I move left, it's moving to the right, which is a problem. And it's looking good for the most part, except looks like I messed up the top side with the yellow. Looks like I have one of the vertices off, so let me go ahead and change this. This is relatively clean compared to the first time I went through this. So the top side, or when I was first designing this, so the top side is over here, and I messed up. Where did I mess up? Okay, I use x2, y2. I want to use x2, y. So now it should look better. There we go, now it looks perfect. As you can see, there's only being two drawn at a time because we checked that. And now we can move on to the next step, which is rotation. So, rotating the angle, I guess, view angle. So we're moving to our room, and in the view, we're going to enable view, all that good stuff, and then make it the same size as the room. So the room is 640 by 480, our view is 640 by 40, perfect. So that's all we really need. That was view 0, so when we rotate it, we're going to modify view 0. So if we add 2 when we press right, we want to subtract 2 from the view angle. So view angle 0, or we say minus equals 2. And then view angle 0 plus equals 2. Okay, so this will set it up. Now we got that taken care of. Let's see if we can get the magical 3D effect now. Something looks kind of off about it, and it's because it's off center. I bet you the tile background in the previous example, or in my demo, helps. So let's make that real quick. Back tile, edit, transform resize 6464, and that's what you want. Okay, so I'm gonna make it all white with a black outline. Yes, and I'm gonna make it too thick just for the heck of it. Alright, go to our room, apply the tile to it. Oh, whoops. Okay. Now it should look perfect. Yeah, that makes it look a whole lot neater. Now you can see that it's rotating around a point. So that is basically the end of the tutorial. That's how you rotate things. But there's a problem that I know that pretty much all of you will come across in a second, so I'm going to go and address that right now. If we add more, it will not look as clean. So you can see that doesn't look clean at all. That's because they're all changing their own rotation values over here, and but they're also changing the angle values, which applies to all of them. So if I have 5 of them, the rotation will be changing at 10, and the view angle will be changing by 10, and the normal rotation will be changing it by 2, which is not what we want. We want them to both change at the same rate. But the problem is the view angle applies to all of them. So in order to fix that, I'm going to go ahead and copy this. I'm going to create another object and call it obj control, or just control, I guess. Control all. Yeah, there you go, I got it. And then in the step event, I'm going to paste what I had earlier. Oh, paste is Control V. Then get rid of the rotation part, and this will apply to everything. And then if we take it out of the block, then I'll take this part out. And now it should work a lot better. I'll just add the control to the room, and now they should move at a nice constant rate. See? There you go. You now know how to create a 3D isometric effect, and it looks really neat. I remember how happy I was when I first figured this out. I forced all of my roommates to look at it. Okay. So that's all for this tutorial. I hope you found it helpful. Please rate, comment, subscribe if you did, and I look forward to seeing you guys in my next tutorial.